Hello. So today we're just going to do something a little bit different. Rather than doing like a specific coding exercise, we might just go through the four random variables, the four discrete ones that we've gone through. Um, so we're going to start from the beginning. We're going to start with Bernoulli, a single trial that has a probability of success p. So what this means is that if the random variable that we produce is less than p, it's going to be a success and we're going to return 1. And if the probability is more than p, or the number that we return is more than p, we're going to return 0. So it's pretty simple, but we're just going to figure out how to code it here. So if our random variable, so np.random.uniform 0, 1, it's all spelled right, is less than p, we'll return 1, and otherwise we'll return 0. We can imagine this as like if we just draw out a big number line like this, so between 0 and 1, in this case, it could be any numbers though, and let's just throw p somewhere. So let's say p is down here. We see here that if this area here is the number that comes out here, we're going to be returning 1. But if we had anywhere here, it's going to end up being 0 because the trial would not have succeeded. So let's print out a couple of them. Bernoulli. Let's try 0.25. Maybe 0.5, so 0.5, and 0.75. So if we just run that, let's just comment these out for now. We can put them back in a second. Did I spell it wrong somewhere? Or is it just because it's not a capital letter on it? Right, now, okay. That should be better. Okay, so all of them failed it. That was pretty slim chances. So we got 1 success there. You can see that they're coming every now and again. They were scaring me there for a second. I thought I did something wrong when it was 3 zeros twice in a row. But yeah, so that's what a Bernoulli trial is. And so let's have a look at another different type of function, the binomial. So this one is very simple. It's just we do a Bernoulli trial a couple of times, and we count how many times we succeed, how many ones we return. So there's a couple more things that we need to store here. We need to store how many things we're doing, so n, the probability of success, so that's p again, we have that one last time, and we need to record how many things we succeed, or how many times we succeed, how many ones we return. So we'll let that equal to r, is the number of successes that we have. And then let's go for I in range n. So n times, we'll be doing this, if Bernoulli p is equal to 1. So you see the way I put 2 equals to the signs there? Because it's a function, you have to make sure you have to go absolutely equal to. We will make r equal to r plus 1. And then at the end we just return r. So let's do that a couple of times. Print, I put a capital there. Print binomial. I would say we'll do it 5 times, probability of 0.2. And let's just copy and paste that a couple of times. So we'll say 3 times. Right. And if we go and print that, we see 1, 1, 2, 1. So we'd expect 1 to be coming out there, because if you do it 5 times, the probability of 0.2, it should come out once. So 1, 1, 2, 1, and so that's the binomial random variable sorted out. Now let's go on to geometric. So geometric is how many trials it takes to obtain 1 success. So how many times will we go through this random variable until we get 1? So we need to again record a couple of things here. We need to record r, which is actually, or let's call it something else here. Let's call it f, the number of failures, because we want to count how many trials it actually takes to get to this successful trial. So for this, we're not going to use a for loop. We're actually going to use a while loop, because we don't know how many it's actually going to take. You know, this could take 5 trials, it could take 10 trials, we just don't know. So while R, so R will be our success, is equal to 0 if Bernoulli P, let's make that a capital, just for sure, is equal to 1. F and R will both go up 1 because we'll have the number of trials that we made and the number of successes both going up by 1. So that'll be F plus 1, R plus 1. Ooh. Else, otherwise, so if the trial is a failure, keep that in, R equals, or F equals F plus 1. And then at the end, we shall return the number of trials, F. So let's print off that geometric one a couple of times. And with a probability, let's say 0.2. And we'll paste that a couple of times again. So you see there you got 14 there a couple of times. That's a bit mad. So you get your 6218 there, yeah. So that's all working out fine as well. Now a negative binomial is similar to geometric in that it's how many trials it takes, but in this case it's to obtain R successes, so how many different successes, instead of just being 1. So in this case again we need to do our number of trials, and the number of successes that is required is already recorded for us because it's right here. We put in how many successes that we want. So while R is more than 0 in this case, let's try and look at it a different way. If Bernoulli P, so if our trial is equal to 1, let's take 1 off of our successes and bring up the number of trials, so the number of trials that it took, or F plus 1. And then again, else, we just keep the number of trials. We need to keep count of how many trials that we take. At the end, then, we will return the number of trials, F. So let's print off that a couple of times. Let's see. Negative. And we'll make R 0.2. Oh, not 0.2. R is the number of successes that we want. So let's say we want 5 successes, and the probability is 0.5. So we should probably be expecting around 10 there or so. So again, let's copy and paste this a couple of times just to make sure that we're all going well. We went a bit farther, but it's just a long name. And see, 6 every time there. Okay, so I probably made a mistake here. Ah, yes. So I just need to indent that else. Then we should be getting all sorts of different numbers. Lovely. Sorry about that. So there's all of our different random variables. If you're able to code these, then you should be able to do all of week 3, no bother to you. You'll be able to plot these and to generate them. For the plotting, it's pretty simple. You'll be asked to make an xVals. And so for I in range, however many trials you want to do, this is just a sample here now, you'll make xVals I equal to I plus 1. And then you'll make your yVals equal to however many trials that you want to get done. So hopefully all that helps, and thank you for watching.